today's video, we are looking in our notes packet. We are on the day 15 in class notes. We spent a few days now on how to graph sine curves and graph cosine curves. Now we're just kind of going to work from a different angle, and we're going to talk about how to write equations of these sine and cosine curves. So our first equation, or our first problem here, write the equation of a cosine curve. Very simple, but sometimes we mess it up. So I will tell you whether it is sine or cosine, and you just have to use that when you write your equation. So if I think about a general cosine curve, that is y equals a times the cosine of b times x minus h plus k. And from graphing these the last few days, we know exactly what the a, the b, the h, and the k do. Those are all the different ways that we can change. The first piece of information I'm giving you is that the period of your cosine curve is 1 pi. So we think about where and how do I calculate the period of a graph. That is by doing 2 pi divided by the b value. Well, if I were to do 2 pi divided by b, and my answer is just 1 pi, what does my b value have to be? Yep, it has to be 2. Because 2 pi divided by 2, the 2's cancel, leaving you with 1 pi. So that's my first piece of information. I know that my b value is 2. The amplitude is 3. Well, I don't have to do anything. A equals 3. My amplitude is 3. The horizontal shift. Now here we are going left pi over 2. So our horizontal shift is left pi over 4. You just got to remember that when we are doing horizontal shift, it is inside, but it is the opposite of what we think. So this is actually going to be plus pi over 2. I think I said pi over 4, but pi over 2. And then the last part here is the vertical shift down 19. So our k is a negative 19. We put all of those pieces together and we get that our equation is y equals 3 times the cosine of 2x plus pi over 2 minus 19. Again, all of this information to the left helped us find the individual a, b, h, and k from our equation, and we put it together. Not too bad, right? Now we're going to do the exact same thing we just did from a graph. So we're going to look at the graph. And when we look at the graph, again, the period is the length of one cycle. And we can see that from one cycle to the next, it's only going to be 2 pi. So from the beginning to the end of the cycle, we see that we have moved 2 pi. And because our period is 2 pi, well, if we do 2 pi divided by b, that just means that our b value is equal to 1. The amplitude, remember the amplitude is your a value, and that is going to be the distance between your levels. So if I'm looking at the top of the wave, the middle of the wave, and the bottom of the wave, I see that the distance between each level is 2, which is going to make our a value 2. Now, something that we have to take a second to look at is our a value a positive 2 or a negative 2? Because the distance is going to be 2 whether it's positive or negative, but the starting point. I circled the starting point. Circling the starting point is so important. This tells me that I'm starting at the top of my wave, the top of the curve, which is why my a value is positive. Now, if I had started down here and this point had been circled, I would have started at the bottom of the wave, making it a negative graph. And when I also, so since we're here, since I'm starting at the top of the wave, that means it has to be a cosine function, because we know sine functions always start in the middle of the wave. And because I have my circled starting point at the top, if it's at the top or the bottom, it's going to be that cosine graph. The horizontal shift and the vertical shift. So we want to think about, where would my graph be starting? I know it's cosine, which starts at 1, and it has an amplitude of 2. So I take 1 and I multiply by 2. So my starting point would be at 0, 2, but it's not. It's over here. So I think about, how did I move to get there? So I would have been starting at 0, 2 because the, again, amplitude is 2. I went to the right pi over 2, and then I went up 2, and that's how I ended up at the starting point, which I was given circled. So we have y equals our a value of 2, which is coming from that amplitude. We determined that it was a cosine graph because we had a circled point at the top of the curve. We went right pi over 2, so it's x minus pi over 2 because anything inside is the opposite, and we went up 2, so that k value is 2. So based on the picture that we have right here, this is going to be the equation of the given curve. Now below that it says, how could I write a second equation for the graph? So I think about, if I want to write a different equation, I just need to change my starting point. This is what I had circled as my starting point. What if I change my starting point to be right here? I think about all of the different information that's going to change. My starting point is now in the middle of the wave, so it's going to be a sine curve. And then I have to decide, I know my a value is still 2 because I still have a distance of 2 between each of my levels, but is it a positive 2 or a negative 2? If I were to look here, I'm going down first, so now my a value is a negative 2. I haven't changed the period at all, so my b value is still going to be 1. Now we think about our horizontal and vertical shifts. If I have a sine curve normally starts at 0, 0. I multiplied it by 2, but that doesn't make a difference because 0 times anything is still 0. When I think about, how did I shift then to get all the way over here? I need to go right pi, and then I would be going up 2. So if I take all that information and write my equation, we have y equals my a value, which is going to be that negative 2 sine, we went right pi and up 2. But that's only if I changed that. What if I had gone the other direction? What if I had chosen this one as my starting point? So if I look here, I'm still in the middle of my wave, so that's still going to be a sine curve. My distance between my levels is still 2, but notice how my graph is going up first. That means that my a value now is a positive 2 instead of a negative 2. Again, my period hasn't changed. It's still the same distance for one wave, so the b value is still 1. Now again, sine normally starts at 0, 0. I multiply that by 2. Oh, I'm still there. So to get to my starting point, there is no horizontal shift, but I have to go up 2. So this one would be y equals 2 times the sine of x plus 2. Again, we can keep on going on and on and on. We can change the equation of our graph at any point by changing the starting point. Okay, there is the end of that video.